Transformer Inrush Current Limiter, Inrush-Limiter T1. In substations and factories, when the transformer is energized by closing the circuit breaker, an inrush current occurs that causes voltage drop, unbalanced current, and waveform distortion. Lightning is commonly considered a threat to power supplies because it causes a momentary voltage drop of less than 100 milliseconds, which can affect various equipment. By contrast, the inrush current that occurs when energizing a transformer can last for several seconds or even minutes. This can cause failures on the load side within the proximity of the transformer, notably relay malfunctioning, undesirable variation in motor-driven processes, undesirable variation in measurement and control systems, personal computer and server shutdowns, malfunctioning household appliances. Inrush current is generated by the residual fluxes in the transformer core, which are released when the transformer is shut down by tripping the circuit breaker. Until now, this aspect of residual fluxes was kept ambiguous. This is because there is no way to directly measure the fluxes, and it is difficult to test for in an actual system. Koudensha has succeeded in accurately assessing the nature of residual fluxes. The top half of this graph shows the waveform for a common three-phase voltage. The lower half is a waveform of the fluxes, which is calculated by integrating the same voltage waveform by time. The waveform is the voltage waveform delayed by 90 degrees. If you captured each phase as a vector, it would look like the diagram on the bottom. This diagram is a three-dimensional representation of the magnetic flux waveform. Let's shut down the transformer by tripping the circuit breaker at timing T open 0. The common understanding was that the fluxes would remain in this state. We found that the waveform of these fluxes converged to a certain value at timing T open 1, in conjunction with a transit phenomenon that occurs after the timing of the tripping operation. This can be attributed to the effects of floating capacitance and energy that gets consumed in the form of eddy current heat loss in the transformer core. In other words, Koudensha has successfully proven through testing and theory that the fluxes at T open 0, which occur immediately after tripping, are not the real residual fluxes. The real residual fluxes are the ones that converge as a transit phenomenon at T open 1. This is a model waveform of the system voltages and transformer voltages and fluxes. After tripping, the residual fluxes and initial fluxes that occur when the circuit breaker is closed repel or reverse their polarity. The scalar difference of the magnetic fluxes becomes large, causing the superimposed state of the fluxes to distort significantly. When the magnetic fluxes in the transformer reach the saturated region, an inrush current proportional to the excess occurs. By controlling the phase angle of the circuit breaker so that the residual fluxes match the initial magnetic fluxes, the flux waves can be kept in the linear region, thereby controlling the inrush current. The Inrush-Limiter T1 is designed to easily fit inside a power distribution panel. Wiring and interfacing is very simple. The T1 requires 110 volts DC for control power. The control circuit requires the primary and secondary voltages of the circuit breaker that will be used to energize or de-energize the transformer. To allow the T1 to control the circuit breaker, input the trip signal of the circuit breaker through a current relay. The T1 only references this signal and never interferes with the tripping operation. Input the circuit breaker close signal. To allow the processor to determine the proper timing for the T1 to act as the interface for outputting the close signal to the circuit breaker. Essentially, the T1 is spliced into the circuit breaker close signal line. These are the results of field testing with an actual power system where inrush current caused problems. The maximum inrush current was 1152 amperes. This shows the results after installing the T1. The maximum inrush current dropped to 171 amperes, thus limiting the inrush current by more than 80%. The Inrush-Limiter T1 has been used in various facilities and systems. It continues to help stabilize power supply systems, such as a 66 kilovolt substation and wind power generation facilities. Kodensha continues to help stabilize tomorrow's power supply infrastructures with our Inrush-Limiter T1. Kodensha, making progress with our clients through technology, creation, and challenges.